What's up, you guys? So this is George from Table 1, Period 7. So the guiding question is, how does diatomic molecule of oxygen satisfy the octet rule? Well, our claim is the Lewis dot structure of a diatomic oxygen molecule demonstrates the octet rule through its sharing of electrons as a non-polar covalent bond. Let's begin with identifying some of these terms. So the octet rule means that the electron has 8 valence electrons, which satisfies stability. So like looking at the periodic table, all of these elements in group 8A satisfy the octet rule because they have 8 valence electrons. And a lot of these atoms, they want to satisfy the octet rule by gaining or losing electrons, which ultimately makes them an ion. But in this case, the molecules bond. And it is through sharing of electrons that the diatomic oxygen molecule demonstrates the octet rule. It also is a nonpolar. It's nonpolar, which means that the atoms, they share the electrons equally. Covalent bond, it is a covalent bond because both the two oxygens are nonmetals, and the bond is formed through the sharing of electrons. They don't add or lose, they simply share. So, looking at how to do the Lewis dot structure for oxygen, we begin with writing O2 out, which is O and O. And to find how many valence electrons, which are the amount of the electrons in the outermost layer, we can easily look at the periodic table and see which group it lies in. The group it lies in will tell you how many valence electrons it has. For example, nitrogen, it is in group 5A, therefore it has 5 valence electrons. Carbon, it is in group 4A, therefore it has 4 valence electrons. Now let's look at oxygen, which is what we want to look at for this video. So oxygen is in group 6A, therefore it has 6 valence electrons. So let's write them out right here. So 1, 2, 3, 4, 5, 6. Let's do it for the next one. 1, 2, 3, 4, 5, 6. And as we said before, the octet rule means that the atoms should have 8 valence electrons to achieve stability. So what we want to do is we want to bond these. So let's create a bond between these two electrons. Okay, now let's count them. 1, 2, 3, 4, 5, 6, 7. Keep in mind, I counted this one because they are sharing the electrons. Therefore, this electron, this atom also has this electron, and this atom also not only has this electron, but also this one. And we counted 7, which is not 8. Therefore, we need to bond this one and this one. Now let's count them. 1, 2, 3, 4, 5, 6, 7, 8. That's a good way to check. You simply count the electrons to see if you have satisfied the rules. So 1, 2, 3, 4, 5, 6, 7, 8. 8 valence electrons. Therefore, the octet rule is satisfied. Now going back to our claim, I do want to talk about nonpolar. And the way we found this is that we subtracted the electronegativity of oxygen, which regardless of the number that we have, let's just say it's 1.5. So let's just say that's for this one, and then 1.5 for this one. Well, we have to subtract them, and we get 0. And when we getting a number below 1.7 means that our the two molecules and their sharing of electrons is equal, meaning that this one doesn't get a closer attraction to this electron. Let's say they simply share the electrons equally. So therefore, this being 0, we have a non-polar covalent bond. Hopefully you guys have a better understanding after watching this video. Thanks for watching.